Hi, welcome to readmeproject.com. The paper you have requested is Unsupervised Traffic Classification using Flow Statistical Properties and IP Packet Layout. Let's have a look on our abstract. In network traffic classification, unknown application is a difficult problem unsolved. Conventional supervised classification methods classify any traffic flow into predefined classes, while cannot handle unknown application without corresponding unsupervised data. Some unsupervised clustering algorithms such as k-means have been applied to group traffic flow automatically, but a large number of clustering clusters are unable to correctly represent a small number of real applications. To address the problem of unknown application, we propose a novel unsupervised approach which has a capability of discover application-based traffic classes and classify traffic flows according to their generation application. In the proposed approach, the flow statistical properties and IP packet payload are used in combination to discover the traffic classes in training stage. Then we introduce a bag of words model to represent the content of clusters constructed by using a flow statistical features and apply latent semantic analysis to aggregate similar traffic clusters based on their payload content. In the testing stage, only flow statistical features are used to classify traffic flows that can protect user privacy and deal with unknown encrypted application without inspecting IP packets. A number of experiments has been carried on a real-world traffic set to demonstrate the effectiveness and robustness of the proposed approach. The network traffic classification aims to classify traffic flows by their generation application. It plays an important role in network security and management, such as quality of service control, lawful interception, and intrusion detection. The traffic classification methods can be based on port numbers, payload content, and flow statistical features and host behaviors. The application of machine learning techniques in traffic classification, particularly using the flow statistics features, generally can be categorized into supervised and unsupervised method. The supervised methods learn a classifier from a set of pre-labeled training samples to classify new traffic flows, while the unsupervised method group the traffic flows that have similar characteristics into clusters. Traffic clustering does not need any supervised training data and has the potential of identifying unknown application, while supervised methods can only classify traffic flows of known application. As new applications are emerging every day, traffic clustering is facing serious challenges. This work aims to address difficult problems without any supervised information, that is, applications can be known to the traffic classification system. To best of our knowledge, this is the first work comparing flow static features and IP payload content to tackle the critical problem of unknown applications. Our major contributions are as follows. We propose a novel unsupervised classification approach which can satisfy traffic flows into small number of application-based classes without any supervised data. We develop a new cluster aggregation technique to discover application-based traffic classes and provide an unsupervised training data by comparing the flow statistical properties and IP packet payload. We propose to represent the content of traffic clusters using a bag of weights model and analyze the cluster similarity by latent semantic analysis. Now let's have a look on our data flow diagram. Start the process, load dataset, then identify statistical features. Then we need to cluster flow statistical features and identify bag of words. Then apply term frequency and inverse term frequency. After that, apply code word clusters. Then find similarity between the code word cluster matrix. Then classify the data based on the code word cluster matrix. Stop the process. Now let's see the demo of our project. First we need to run main.java in unsupervised package. Select data and load the input dataset. Click load project, then click load. Dataset loaded successfully. Click view. This is the dataset we are going to use in our project. It will show the date, time, stamp, source IP, source port, destination IP, and destination port, and the protocols used in the source IP and source destination IP, and total packets forwarded and total volume of the packets and flow of the packets. Then click next. Select flow statistical features. Then view flow statistics. Then we need to cluster the flow statistics. Give the number of clusters which we need to cluster the input data. Then click next. cluster value calculator, then click next. Click cluster. It will show the clustered results over here. Cluster 0, cluster 1, like that. Then click next. Select records and identify protocols. Then we need to extract backup words from these protocols. Click next. Now we need to calculate term frequency and inverse term frequency. Extract code word clusters, then code matrix. So the code word clusters and code matrix has been extracted now for each and every code words. Then click next. Based on the code word matrix and the clustered results, we need to identify similarity. Once the similarity has been extracted, we need to extract cluster aggregation. The cluster aggregation has been extracted. Then we need to identify flow classification. The final result is based on the code word and the classification model and the protocols and source IP and destination IP used in the classification model. Click performance analysis. It will show the accuracy of the proposed method compared with the another methods like C45, KNN, SVM, etc. That's all the process over. Thanks for watching clickmyproject.com.